So now let's talk about the equality property of logarithms. Now this seems like a pretty simple idea. It's just basically saying that if you have two positive real numbers and they're equal, then their logarithms are also equal. That seems pretty straightforward. So here we have it in more of a mathematical definition form. So if the log base b of m is equal to the log base b of n, then m and n are equal. Okay, so this works in both directions. This if and only if, this is again the if and only if, which is sometimes abbreviated as if and only if, IFF. It just means that this statement works in both directions, right? So either if the two logs are equal, then the arguments are equal, or if the two numbers are equal, then the logs of those numbers are equal. This is a really simple idea, but it's very powerful for solving exponential equations, which you'll see in a little bit, because it allows us to take two equal things and take the log of both sides of an equation. So I have a little bit of an explanation of why, kind of a proof of why this is true, but I'll let you read it yourself. let's get to we want to get to the business of doing examples. But before we do that, I want to point out this warning. We have to watch for extraneous solutions when solving logarithmic equations. Okay, so when you solve the logarithmic equations, always check your solutions to make sure that they actually work. Now, the issue is that the logarithm is not defined for 0 or any negative numbers, right? We can't take the log of a negative number, because remember what it's asking. It's asking what is the exponent on a positive real base that gives us that result, that number that we're trying to take the log of. And if we try to, we can't, there's no, there is no exponent we could possibly raise a positive real base to that would give us a negative number, okay, or a 0, right? So if the base is positive real number, there's no exponent that that gives us a negative number. Okay, so we have to be careful. We can't take the log of a 0 or a negative number. So let's take a look at this example. Now, remember, if we have two logs that are equal to each other, then their arguments have to be equal to each other. So these are pretty straightforward. We're just going to pull those numbers out of the logarithm and set them equal to each other. So we know if the log of x plus 4 is equal to the log of 3x plus 8, well, that just means that x plus 4 is equal to 3x, minus 8, 3x minus 8. I think I said plus, and then it's just algebra, right? We just need to rearrange this equation. So let's subtract x from both sides and add 8 to both sides. So we end up with 12 is equal to 2x, 2x, right? Because we're subtracting x from both sides, 2x. And then we can just divide both sides by 2, which gives us x is equal to 6. All right, now let's check it. Now this is a nice positive number, but we should check it. So let's check. Well, what are we going to do to check it? We're just going to put it back up into that original equation. And so you can see the log of 6 plus 4 is equal to the log of 3 times 6 minus 8. Okay, and we just have to ask ourselves is that true, right? This is saying the log of 10 is equal to the log of 18 minus 8, which is also 10. So yes, it works. All right, now let's take a look at this next one. All right, so again, we're just going to pull those arguments out of the logarithm, right? Because if the logs are equal, then their arguments are equal. So we get x squared minus 8, or x squared minus 1 is equal to 8. Right, I'm going to add 1 to both sides, which gives me x squared is equal to 9, which means that x is equal to what? Now don't forget, take the square root of both sides, but x could have been positive 3 or it could be negative 3. Okay, either one of those are the are the answer to x squared plus 9, or sorry, x squared equals 9, right? Either x is 3 or negative 3, because if we square a negative number, we get a positive 9. So, all right, so now we have two answers, but let's check them. We need to check them both, right? So we're going to check. I'm just going to take those numbers and put them back into the original equation. So log of 3 squared minus 1 is equal to the log of 8. Does that work? Yes, because we have 9 minus 1 is 8. So log of 8 is equal to 8. Log of 8 is equal to log of 8. That works. Let's check the other one. Now again, we're putting negative 3 in for x. So that means we have to square negative 3. The whole thing with the negative. It's negative 3 times negative 3, right? Minus 1 is equal to the log of 8. So I put the numbers in. Now when we square a negative 3, don't forget the parentheses around it, because the square of negative 3 is negative 3 times negative 3, which is positive 9. Positive 9 minus 1 is 8. And so the log of 8 is equal to the log of 8, and that checks out. All right, let's do a couple more. Again, we're just going to pull the argument of the logarithm out because we have this equality property of logarithms, right? So x squared plus 4x is equal to x minus 2. All right, then it's just algebra from here. All right, so let's do it. Well, I'm going to subtract x from both sides. So 4x minus x gives me a positive 3x, and then I'm going to add 2 to both sides. I have a quadratic, right? So I want to move everything to one side and set it equal to 0, right? So I want to just subtract. I'm going to move the x minus 2 to the other side. And then we have a nice quadratic equation, which is easy to factor. We know that we can factor this into x plus 2 times x plus 1. Whoops, x plus 1. X plus 1. Okay, and that's equal to 0. And so that means that x is either equal to minus 2 or minus 1. Okay, so those are our two solutions, but don't forget to check. So let's go back up to the original equation and check it out. I know it seems like a pain, but we always have to check it out. All right, so we have the natural log of minus 2 squared plus 4 times minus 2, right, is equal to the natural log of minus 2 minus 2. All right, well, okay, what does this give us? This is a 4 minus 8, so that's minus 4, and this is also minus 4. But remember, we cannot take the log of a negative number, right? We cannot take the log of a negative number because this logarithm has a positive base of e, and there's absolutely no exponent that we can raise that positive base of e to in order to get a negative number. So this doesn't work. So this does not work. So this is no, that doesn't work, which means that the minus 2 doesn't work. That is not a solution. It doesn't work. All right, so let's try the other one. We have the natural log of, okay, we're going to put in minus 1. So we get minus 1 squared plus 4 times minus 1 is equal to the natural log of minus 1 minus 2. Again, we have a problem because, just over here you can tell just by minus 1 minus 2 is a minus 3. We can't take the log of a minus 3 because there is no exponent that we can raise a positive base to in order to get a negative exponent. Or sorry, a negative number. Okay, there's no exponent that will give us a negative number. So this again is not going to work. So this is not a solution either. All right, well, what is the solution then? There is no solution. There's no solution here. So that's our answer, is that there is no solution. All right. All right, there's one more here in this example. And okay, so we have 2x minus 4 is equal to 3 minus 5x. Okay, now I probably didn't need those parentheses there if I pulled it out. So let me take that away. So 2x minus 4. All right, it's just algebra. So I'm gonna add 5x to both sides. I get 7x, and then I'm gonna add 4 to both sides. So 7. So x is equal to 1. That's what it's telling me. But again, we have to check it. So let's check it. What happens? We take the log of 2 times 1 minus 4 is equal to the log of 3 minus 5 times 1. Okay, that's just plugging in that x equal 1. And notice again, we have a problem because this gives us the log of minus 2 is equal to log of minus 2. Now, that seems on the surface like, okay, that must be true, but there is no exponent that we can raise a 10, a positive 10 to get a negative number. So this doesn't work. All right, so again, that doesn't check out, which means that this is not a solution. And again, that's the only possible solution we found. So there is no solution to this logarithmic equation either. All right, that takes care of the equality property of logarithms. And the next thing we're going to look at is the product property. So I will meet you in the next lecture. Or in the next the next video, not the next lecture. It's still the same lecture. We'll meet you in the next video.